Hello everybody, my name is Achille Ferigetti and I am part of the team that in Artemis is responsible for designing and implementing the so-called data infrastructure, and especially the conceptual framework on which the heritage digital twins are built. In this video I will try to introduce the basic concepts behind this activity. And more specifically, I will try to provide an overview of what a digital twin is and of how this smart and innovative model can be used to shape the knowledge in the cultural heritage domain. So let's start by trying to explain what we mean when we talk about digital twins. Essentially, we can say that a digital twin is a digital artifact created to replicate a real-world object. It can also replicate a real environment or a real system, but what makes this concept so amazing is that the digital twin does not reproduce only the external appearance and shape of the real object, but also its functioning and the way it works. A digital twin, in fact, is more than a static replica of an object, like a 3D model. On the contrary, it is an interactive, a living digital artifact that constantly reproduces and simulates the behavior of the real object, potentially in all its aspects. More, it can even communicate with the real object in real time, for instance, by monitoring what's happening on it. And what is also nice is that it can even predict future behaviors of the object, that is, the shape, the status, and the conditions that the object may assume in the future. So the initial idea of digital twins started in the industrial world, where people were trying to make production more efficient. So they created the digital version of the products they wanted to manufacture before actually starting the real production. And this was made in order to simulate different production scenarios and optimize the costs. And on the other hand, they used and still use this technology to monitor the quality, the behavior, the efficiency, and so on of their final products once they are actually created and distributed on the market. For instance, a very famous example of this is Tesla. The Tesla company do this monitoring all the time. Their cars are constantly in communication with the Tesla servers, so they can be monitored, tested, optimized, and even improved while you are driving your car. Afterwards, digital twins have been gradually adopted in many other disciplines. For example, they have been widely used by NASA to simulate space flights and also to simulate the extreme conditions in which the astronauts operate during their space missions. Another example is environmental engineering and urban planning, where the digital twins are used for creating perfect replicas of buildings, of spaces, and even of entire cities. This is what they are doing, for example, in Singapore, in Bologna, and now in many other cities. Digital twins in this case are very useful, for instance, to plan and analyze the evolution of the city, to see, for instance, the impact of urban decisions on the environment or on the traffic, the pollution, and in general on how people actually live and move through a urban space. So when this model was finally adopted in cultural heritage, the scholars realized that in this field there is a greater complexity that even goes beyond the external shape and the physical composition and the mechanical functioning of the objects, since it also includes aspects that are purely conceptual and, we can say, immaterial. But these aspects, nevertheless, are equally important and in some way perhaps even more relevant than the physical ones for these disciplines. In fact, If we think about it, cultural objects actually derive their identity from their history and from the immaterial aspects that surround them. These immaterial elements form a sort of invisible double nature that actually makes cultural objects what they actually are, that is, cultural, without which they will be nothing more than simple physical objects. We also have intangible entities, which cannot be confined in any way to any physical element, even though they involve the use of physical objects in their life cycle. This is what is commonly defined, and also UNESCO defines, as intangible heritage, a kind of entities that include, for instance, cultural traditions, such as the art of creating violins, and cultural events and manifestations, such as the famous Palio, that is held annually in the city of Siena. It is interesting to note that when these manifestations of intangible events are over, nothing tangible remains of them. Typically, what remains is the memory of these events. And the memory is a key element in intangible heritage, and is usually preserved in documentation, that is, in historical records, literary sources, images, videos, audio, or simply in the words, in the witnesses of the people who participated in these events. So, if cultural knowledge actually represents the non-physical, let's say the immaterial side of cultural heritage, that is, a knowledge that frames their identity and gives cultural significance to them, then we can say that it is precisely this complex set of information that we need to capture and organize in order to create digital objects that are truly able to mirror cultural entities. So, with this concept in mind, we have defined heritage digital twins as the complex of all the knowledge that is available to scholars about a certain cultural entity. This, of course, involves the knowledge on the material and the structural aspects of cultural entities, of course, especially together with their environmental conditions, but it also includes the knowledge relating to their history and the various events in which cultural entities were involved during their lifetime. That is what we call the historical documentation, that, as we said, has a central role in their definition. So at this point, the real question is, how can we organize all this complex knowledge in an efficient way? Obviously, we need specific tools that should be powerful and flexible enough for this kind of activity. Fortunately, we have ontologies that can give us an excellent answer to this question. And in the next part of this presentation, we will try to see why. So, a few words on ontologies. They can be the right tool because they are designed exactly to provide the conceptual basis and the grammar to represent all this kind of knowledge in a formal way. Formal in this context means in a way that is both readable by humans and also understandable and processable by machines. The ontologies, in fact, are able to represent real-world entities exactly because they use a specific grammar and the same mental categories that we humans employ to describe the real world. In fact, they are like digital windows open onto the real world, through which we can observe and describe people, objects, events, and we can also give them names and organize them in categories using, for instance, concepts from shared vocabularies. Ontologies also give us the power to establish semantic connections between these elements and build narratives in digital form that can reproduce the facts, the events, and the condition that we observe in the real world. For example, we can model and describe events that happened in a certain place and then connect them to the people and the objects that were involved in these events, and so on. Fortunately for us, in the field of cultural heritage, there are already several of these ontologies that can be used to model complex information and build digital twins. For instance, those of the CDOC-CRM ecosystem, the famous pyramids that you can see here, offer many of the necessary building blocks to describe different documentation available in different form, such as digital documents and data sets, 3D models, historical and scientific information. We have a lot of this information in Artemis. So ontologies are the right tool for integrating this kind of knowledge. The philosophy of CDOC-CRM makes this ontology very flexible, since it is based on the synergy between a core ontology and various compatible extensions that allow for the implementation of a sort of modular architecture to represent knowledge. Based on this approach, we are building what we call the Artemis semantic model by assembling and combining different ontological components as if they were Lego pieces to play with. This mechanism also allows for the reuse of existing ontologies, such as the AOCAT model that was developed in Ariadne, and other models defined by other projects and other initiatives. Artemis also relies on very popular and well-attested shared vocabularies to provide additional levels of standardization to the information and to make them more interoperable in this sense. For example, the Getty Art and Architecture Thesaurus, the AAT, is used to define types of cultural objects, and the Periodo GeoGazetteer is used for the unambiguous identification of cultural periods. So, thanks to the ontologies, it's possible to model cultural entities in all their facets. It is also possible to represent their identity and to define it, to describe their origin and their life cycle in an unambiguous way, and it's also possible to spatially and temporally relate them to the events that created them and in which they were involved during their existence. The diagram that you see in this slide, for example, shows how this famous artifact, the Rosetta Stone, can be represented with the ontology as a physical object, a man-made artifact, and how it's also possible to describe the events in which this stele was involved. In this case, a digitization activity, which created a 3D scan of it, and a scientific analysis, and multispectral scan in this case, which produced a series of information useful for the scientific study of this cultural object. Both of these activities are typologically defined by means of the shared vocabularies and uniquely identified by means of persistent identifiers. What is nice, as you can see, is that through events and relationships, digitized by, analyzed by, it is possible to link digital objects with those of the real world in a dynamic and diachronic way, by relating them to the real cultural entities through the processes by which they were created. And this is one of the bases on which our digital twins are built. Using this kind of relationships is also possible to distinguish the real-world entities from the digital objects that represent them, as in the case of the digital image at the bottom of the schema, which depicts the stele. This allows to overcome any possible conceptual or linguistic ambiguity when we describe and we talk about digital or cultural objects. It is also important to note that not all the information available in Artemis is already modeled using an ontology. The information needs to be, in a way, remodeled, transformed, and readapted to be made semantically consistent and interoperable. For this reason, together with the ontology, we have also defined several strategies for standardizing knowledge according to the ontological schema. And these fundamentally consist of collecting and preparing the data, both the existing and the new one that will come, and in transforming and converting them into the Artemis ontological format to create a meaningful and well-structured knowledge graph. The final step of this pipeline involves inserting all this information into a semantic database to implement the real knowledge graph, which is a tool capable of understanding the semantic meaning of the stored knowledge and making it searchable and usable by both scholars and by the services that will interact with the digital twin. This is a screenshot of the tool that we have chosen to implement this model, GraphDB, which is a powerful semantic database which constitutes the true engine upon which the knowledge base is built and which constitutes the heart of our digital twins. In particular, GraphDB is able to interpret the semantic language in which the data is expressed. You can see an example of this on your left-hand side, and represent it as a knowledge graph on your right-hand side, showing the different entities, their characteristics, and the relationships that link them, just as you can see here, in order to implement this complex knowledge graph. In this way, the knowledge relating to cultural heritage is represented in a semantic fashion under the form of a knowledge network, in which all is interconnected and ready to feed the requirements of the digital twins. So this is what we are designing for managing the knowledge about the cultural entities that we want to study and preserve. And this, more or less, is the philosophy and the technology on which we are building our digital twins in Artemis. So this concludes my presentation. That's all for this video. I hope you enjoyed it. Thank you very much for your attention.